This is the Unit 6 Review Part 2. Problem number 14. It wants us to find the measure of angle 1. Alright, so this is on the inside of the circle. So what I'll do is add the two arcs and then multiply by half. So the measure of angle 1 is the sum of the two arcs times a half. So 1/2 times 110 plus 40. Well, if I add 110 and 40, that'll give me 150, and half of 150 is 75. In number 15, this time the vertex is outside of the circle. So in this case, I need to subtract the two arcs and then multiply by half. All right, we always start with the larger arc first. So that's going to be 65 minus 25. And that's because we always want a positive number. Half of 40 is 20. In number 16, write the equation of a circle with a center at -2, 1, and a radius of 3. All right, so my equation is x minus h squared plus y minus k squared is equal to r squared, where my h and k is -2, 1, and my r is 3. And so all I'll have to do is plug in the -2 and the 1 and the 3. Let's clean this up. This double negative becomes a positive. And when I square 3, I get 9. In number 17, it wants us to graph this circle. So I'm going to go ahead and fix this a little bit. I'm going to write it like this. So now I can really see my center. My center is the opposite of what's inside the parentheses here. Well, the opposite of 0 is just 0. But the opposite of -4 is +4. And then my radius is the square root of this guy. And so my radius is going to be 5. So 0, 4 would be on the y-axis right here, and a radius of 5, so go left, right, up and down, and then connect these with a smooth curve. In number 18, this is an inscribed quadrilateral, and it wants us to find the measure of angle C. All right, so we know that the measure of angle A is 75. And let's see, that means the measure of angle C, well, that's going to be its supplement. So 180 minus 75, and that's 105. In number 19, arc AC is 120. Find the measure of angle ABC. All right, so for this one, it's going to be half the difference of the inscribed arcs. Well, if arc AC is 120, that means this guy here, arc ADC, well, let's see, 360 minus 120 is 240. So this larger arc, the major arc, is going to be 240. I don't know why I wrote 120. All right, and so then it's going to be half the difference of these arcs. So 240 minus 120, and then half of that. That's going to give me 120, and half of 120 is 60. And that's what the measure of angle ABC is. In number 20, if the major arc is 267, what's the measure of the minor arc? Well, the major and the minor add to 360. So if I take 360 and subtract the major, let's see, that's going to give me... how about 93 degrees? In number 21, okay, so this one is where I've got a tangent and a secant. And so what I do is I square the tangent, and that's going to be equal to the outside times the sum of the whole thing. So it's going to be, the whole thing is going to give me 8. And so this is going to be x squared is equal to 2 times 8. And so x squared is equal to 16, and the square root of 16 is 4. In number 22, we have a circle with this equation. Is this point on the circle? Well, let's find out. Here's how we'll do this. Let's go ahead and, since we know that the radius is the square root of 225, and so that's going to be 15. So if I find the distance from the center, which we know is 4, -3, to this point on the circle, we'll call this x2, y2, and if that equals 15, then we know it's on the circle. So I'm going to call my center x1, y1, whoops, and then I'll put it into this, the equation, my distance formula. All right, and so this says x2 minus x1 squared plus y2 minus y1 squared. And if this equals, well, 15, then we know it's going to be on the circle. All right, so 16 minus 4 is 12 squared is 144, and this is going to be 9 squared. Well, that's 81. 144 and 81 is the square root of 225, which equals 15. So yes, that one is on the circle. Let's do the same thing with the second point, 14, 8, x2, y2. So r is equal to x2 minus x1 squared plus y2 minus y1. And if that equals, well, square root of 225, then we're good. All right, so let's see. 14 minus 4 is 10 squared. It's 100. 8, that's going to be 11 squared. And I believe that's 121. And so when we add these together, that equals square root of 221, which is not 15. And so this one is going to be no. All right, in 23, find the value of x. All right, so these are two chords, and the rule is the products of the two segments should be equal. So I should multiply 6 times x, and that should equal 2 times 15. So 6 times x is equal to 2 times 15. 6x is equal to 30, and divide both sides by 6, so x is equal to 5. In 24, write an example of each of the following. A radius. Well, that would be OD. A radius is from the center to the circumference. It could also be, though, OC. That's also a radius. Or how about OB? That is also a radius. All right, so now a secant is going to intersect the circle twice. And so the secant in this problem is this guy right here. Okay, and that's going to be line ED. Tangent is only going to intersect the circle once, and so I'm going to call that FD. FD only intersects it once, and its point of tangency is going to be right here. This is the point of tangency at D. Now, a chord is going to intersect the circle twice, but it is a segment, and so its endpoints are going to be on the circumference of the circle. And so there are two in this case. We could either, let's see, AB is one of them. That guy is, let's see, I'm going to go ahead and AB. This would be a chord, but also CB is a chord, and that is a diameter. It's a special type of chord where it goes through the center. And then let's see, is there another one? How about if I just considered E to D and wrote it as a segment? Notice there are no endpoints on this, like in this one. This one, there's little arrows. That means it continues. This one is just the segment. All right, so now let's talk about the minor arc, major arc. Minor arcs are going to be less than 180. So a minor arc, we could call that, how about BD? This could be a minor arc. Okay, there's lots. We could also say ED, AB. These are arcs that are less than 180 degrees. A major arc is going to be greater, so how about And it's also going to need 3 letters. So how about BCD? From B to C to G. That is a major arc. A central angle has a vertex at its angle, so how about angle DOB? That is this angle right here, from D to O to B. An inscribed angle is an angle that has its vertex on the circumference of the circle. And so an example of an inscribed angle is angle ABC. This guy here, A to B to C. That would be an inscribed angle. And of course the center is 0.0, or 0.0, not 0. All right, problem number 25 says find the length of the arc intercepted by a central angle of 80. Okay, so a central angle has its vertex at the center, and whatever its angle is, if this is 80, that's going to be its arc. These are congruent. What is 115 in radians? Well, 115 degrees. If I wanted to convert this to radians, I'd need to multiply by pi over 180. When I multiply by pi over 180, the degrees symbol cancels, and I can multiply straight across. 115 pi over 180. I can reduce this, so I would divide by 5 on both of these. Let's see, 115, I'm going to need to get my Desmos. (115) divided by 5 is 23, and then let's see, 180, whoops, go on the next row. 180 divided by 5 is 36. So this would reduce to 23 over 36. Pi. Don't forget the pi. In 27, write the equation of the circle. All right, so this is x minus h squared plus y minus k squared is equal to r squared. All right, first thing I want to do is find my center. So that's going to be 1, 2, 3, negative 1. My center is 3, negative 1. This is my hk. And then from the center to the circumference, that's going to be 1, 2, 3, 4, 5 units. So my r is equal to 5. When I plug it into my formula, it's going to be x minus 3 squared plus y minus a negative 1, so that's going to be plus 1 squared is equal to 5 squared, which is 25.